Hello all, welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, write a Java program for printing the multiplication table. Let me answer this question with practical demonstration. It's very easy to print a multiplication table. We can even collect the input from the user, like whether the user want to get the multiplication table for 2, okay, 2 ones are 2, 2 to the 4, 2 threes are 6, like that. Or if the user want to get the multiplication table for 7, 7 ones are 7, 7 to the 14, like that. Or if the user want to get the multiplication table for 10, 10 ones are 10, 10 to the 20, 10 to the 30, and so on. Whatever it may be, we'll collect an input from the user, and based on the given input, we'll print out a multiplication table for that particular number asked by the user. So for that, I'll switch to this Eclipse IDE, or I'm going to create a new class. I'll just name this class with some random name, let's say class 19. I'll create a main method here. And inside the main method, I'm going to write this code where I would like to collect the input from the user. So with the help of scanner class, we can collect the input from the user. Scanner is equal to new scanner. Like this, I'll create an object for scanner class, and I will import this scanner from java.util package. After importing, here in the constructor, we have to provide system.in. So it will be ready for intaking the input from the user. Now system.out.println, we have to inform the user during the runtime to enter any number. Enter any number, okay, to get multiplication table. To get multiplication table like this, I'll print something to the user. So by looking at this, user will give some number, okay, 1 or 10 or 7 or 6 or something the user will give. And we'll collect the input from the user that for which number the user wants the multiplication table. We'll collect here next int, sorry, scanner dot next int. This will collect the input from the user, guys. This next int will collect the input from the user, and that I'll store here int number. Okay, now I'll write the code like this. For int I is equal to 1, I less than or equal to, generally multiplication table will have a number multiplied by 1, 2, 3 up to 10, right? I'll go up to 10, 1 to 10, I plus plus. And here I'll go inside the for loop and print out this one, system.out.println. Okay, system.out.println. Here I'll print number. This number I will take whatever the number that user has entered. I'll use a concatenation operator and say multiplied. You can say x or something. In mathematics, we use x, right? 9 into like that. Okay. So x, then here I'll say plus this I. The value of I will go from 1 to 10. As per the iterations, I'll give that, I'll concatenate that I. I'll say is equal to, here I'll get the value. Plus, what is the result? I have to multiply this number with I. So number into number multiplied by I. Okay, here in Java, we have to use asterisk symbol for multiplication. In the circular brackets, I have provided this so that this will be performed first and then concatenated with the string text. Okay, so number multiplied by I. In the first iteration, I will be 1. So if the number is, let's say 9, 9 ones are 9. In the second iteration, I will be 2, 9 to the 18. Last iteration, number will be again 9, but I will become 10, 9 tens are 90. Okay, like that kind of. And at the same time, I would like to, as a best practice, I have to stop this memory leak or resource leak happening here. We have to close that object, guys, as the warning message is saying, we have to close the scanner object. We'll close the scanner object and run the code here, right click, run as Java application, and observe that enter any number to get multiplication table. Okay, if I give 5, 5 ones are 5, 5 twos are 10, 5 threes are 15, 5 fours are 20, 5 fives are 25, 5 sixes are 30, 5 sevens are 35, 5 eights are 40, 5 nines are 45, 5 tens are 50. If you give any other number, let's say 6, let's give any other number like 6. Press enter, 6 ones are 6, 6 to the 12, 6 3 are 18, 6 4 are 24, 6 5 are 30, 6 6 are 36, 6 7 are 42, 48, 54, 60. Like this, you can print any numbers multiplication table. Okay, you can also go with, let's say 10. You see, 10 ones are 10, 10 to the 20, 10 tens are 100. Like this, you can write the logic, guys, for printing the multiplication table for the given number that is inputted by the user. So hope, guys, with practical demonstration, I've answered this question for you. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, write a Java program for printing the prime numbers. Let me answer. Let's say the user has given some input and till that input number, starting from the 1 till that the number that is given by the user, in that range of numbers, what are the list of prime numbers we have? We have to find. Let's assume that you have to write a Java program for printing the prime numbers till the number, okay, list of prime numbers till the number that is given as input by the user. First of all, to understand this, to write before we write logic for this printing the prime numbers from 1 to whatever the number inputted by the user, that range, we have to know what exactly are prime numbers. First, we have to know what exactly are prime numbers. Prime numbers, first rule of prime numbers is should be greater than 1. Prime number should be greater than 1. First thing is that prime number should be greater than 1. And second thing is that numbers can be called as prime numbers when they can be only divisible by, okay, should be able to divisible by 1 and itself. You see, if you take a number like 5, okay, if you take a number like 5, to check whether that 5 is a prime number or not, it should be only able to divide by 1. Can you divide the number 5 by 1? Yes. 1 5 is 5, you can divide it. Zero remainder is coming. That's good. And can you divide the number 5 with 2 by getting remainder 0? That is not possible. 2 to the 4, 1 will be the remainder. So 2 is not properly divisible by 5 in such a way that remainder 0 will come. So if you go with 3, can you divide the number 5 with 3? 3 ones are 3, remainder 2 is coming. So it's not divisible by 3 properly. Then 4. 4 ones are 4, remainder 1 is coming. Again, the 4 is also not able to divide this 5. Then finally, I'll try to divide the number 5 by itself. That is 5 by 5. 5 ones are 5. Remainder 0 will come. Any number which is greater than 0 and that can be divisible by 1 and itself by resulting as a remainder as 0, such kind of numbers are called as prime numbers. Okay. Whatever the numbers we have, okay, which are greater than 1 and at same time they are divisible by 1 and itself by giving the remainder as 0. When you divide that prime number by 1 itself, if that is giving remainder 0, in other numbers, if it's not giving remainder 0, such kind of numbers are called as prime numbers. Okay. So they should be divisible by 1 and itself, should not give the remainder 0 when divided by other numbers. Okay. So those are prime numbers. So now the requirement is to write a Java program for printing such list of prime numbers starting from 1 till the number given as input by the user. Till the number given as input by the user. So I have to write some logic, guys. For that, I have to write some logic. How to write the logic here? I'll write the logic like this. Just observe here. I'll just give a random name, let's say class 20 with main method I'll create. I'll try to intake some number as input from the user till what range I want to print the list of prime numbers starting from 1. 1 is not a prime number anyhow because the prime number should be greater than 1. So all the logic will write in this code so that everything will be validated and only the prime numbers in the given range of 1 to that particular number will be printed. What will be the real prime numbers will be printed. So Control Shift O, the scanner class will be imported from java.util package, and here in the constructor we have to pass system.in. Now I have to give some instruction to the user with the print statement saying enter any number. Enter any number. Okay. So if the user enters some number like 55 or 66 or whatever it is, 78 or whatever it is, till that range will print the list of prime numbers starting from 1. Okay. So here I'll collect the input from the user. Next int, I'll say int number. Till this range of number, we have to find what is a prime number, what is not a prime number in that range. For int I is equal to 1, I less than or equal to this particular number. This is a range, right? I have to find out in this number 1 to this particular number given by the user till that range, what are the list of prime numbers I have to find. I plus plus and here. So I can write the logic here, but it's better that it will be easy if you create one more method here, public static void. Public static void for now, I'll write void here. I'll change the things later. Is prime number or not? Is that is a prime number or not? I have to call this method from this for loop. Okay. I have to call this number from the for loop, right? Like this. If condition, I'll write if is prime number, I'll call this method like this. Okay. So this particular method should return either true or false. Okay. So is prime number I have to pass the value I here. For the range of numbers I'll pass, every time I'll call this method and find out whether that given number is a prime number or not. Okay. So if this is true means system.out.println, I'll print the number. Okay. I'll print that number. I'll simply write on print and say I, and then with some space. Okay. If that is a prime number, then only I'll print. If it is not a prime number, I'm not going to print. If it is false, I'm not going to print. The iteration will continue. But here, Boolean value should be written. Here by default, I'll return true here. Okay. But I will return false in different cases. Okay. I'll try to return true. If this is a prime number, I'll return true. Save this. So is prime number over the mouse is prime number. Here I have to give the parameter. Let's say int. Okay. So int something like some number or n or something you give. Okay. Whatever the number that is coming. I have to check whether this particular number, the I is being passed here for every iteration from 1 to that given number by the user. That range of numbers will be passed. And this is prime number will be called the number of iteration. The for loop will go from 1 to number. Okay. So starting initially what is prime number will call with value 1 will be passed to this number. Number will be 1. Is this 1 is a prime number or not? How to find out? I have to see the if condition. First of all, I have to write a if condition saying if n is less than or equal to minus, less than or equal to 1. If it is equal to 1 also, it's not a prime number. Okay. If it is less than 1 also, it's not a prime number. So I have to return what? If it is not a prime number, I have to return false. So in case of first iteration, what happens? I is equal to 1 will be there, 1 less than or equal to some, let's say the user has given some number like 56, 1 less than 56 is true, will go inside that for loop and is prime number of I is 1, right? I is 1. So is prime number 1 will come. And here 1 is less than or equal to 1. If n is 1 or n is less than 1, in both the cases, it will return false. So here you see, should be greater than 1. Prime number should be greater than 1. So if in case the number given is 1, it is not a prime number. So I'm returning false. The return type is Boolean. So I'm returning false. And since the condition will become false, it will not print the number. It will go to the I++. I will become 2 now. 2 less than or equal to number, whatever the 56 number, let's assume. Is prime number, is 2 a prime number? 2 will be passed here. 2 is less than or equal to 1. 2 is neither less than 1 nor equal to 1. So it will not return false. But here I need to check another condition. If it is not like that, else block I'll take. And here I need to find out whether that particular 2 is a prime number or not. For that, I have to write a loop here. For int j is equal to 1, j less than or equal to, here I have to do one thing, guys, okay? I have to divide this number n. If it is greater than 1, if the number given is greater than 1, we'll go to the else block. And in such cases, we have to see whether that particular number is only divisible by 1 and itself. Only when in case of 1 and dividing that particular number by 1 and itself, you are getting the remainder 0. In all the other numbers, we should not get the remainder as 0. I have to check. Okay, how to check that? Okay, so we can do one thing like this. For example, j is equal to 1, j less than or equal to n, I can say. Okay, j less than or equal to n, j plus plus. I'll write like this, but you should not be writing like this. You should not be writing like this. It should be only divisible by 1 and n. 1 and n, it should be divisible, but it should not be divisible by any other number between 1 and n. So if you want to write a basic logic, you generally write like this. Okay, 1, 2 less than or equal to n, we'll say. And only 2 times it should be divisible. Otherwise, it should not be divisible. Here, I'll write the else block. In the else block, I'll say int count is equal to 0. Here, I'll say if the number modulus, if that particular number is divisible by j, and when dividing by j, if you are getting the remainder as 0, I'll say count plus plus. Count plus plus. Only 2 times. Only 2 times it should be divisible. That is for 1 and the number itself. If any other numbers in between this 1 and n is able to divide that number, that is not a prime number, right? After doing this, here count will happen and all those stuff. Okay. And here I'll write the code like this. For every number, I'll write the logic here. This for loop will go on. Some count will come. Here I'll write the code like this. If count is greater than 2, if the count is greater than 2, that means this particular number is not only divisible completely by 1 and itself, in other numbers also you are getting the remainder as 0, then only count will become more than 2. In that case, you return false. Else what? Return true. Like this, you write the code, guys. You don't have to write else actually. Else also, it's okay. You write also. But if you don't return anything here, by default, it will come out the for loop, and after this, it will return simply true. If this any of these conditions are not matching, it will return true, guys. If it is not going to, if after if block, either it will return false here, or in the else block also it may return false when the number is divisible by 1 and itself. Apart from that, it is divisible by any other number, then you are going to get the return as false. If all these things are passed and return false is not happening, finally you can return true, saying that that particular number is a prime number. And here scanner, you just write down scanner dot close object, so that warning message will be gone. So this is the logic we have written, guys. Okay. Anyone can think about this logic if you know the basics of prime number. Prime number should be greater than 1. And when you are trying to divide the prime number should be divisible by 1 and itself. And only in the case of 1 and itself, the number itself, when you try to divide the number by itself only, it should give the remainder as 0. Only when you try to divide the number by 1, then only it should give the remainder as 0. Any other number in between 1 and that prime number, that particular number, if you try any other number is able to divide that number and giving the remainder as 0, means that is not a prime number. Okay. So with this simple logic, I have written the code, guys. Okay. People write some other ways and all, but this is the simplest way that people can write the code with, and code for. Okay. What is the problem here? Save this code and see if errors are there. No errors. So let's run this code and see what is happening. I'm just reducing the number of lines here. Okay, so that, okay, just writing it so that the spacing I have given, that's okay. That's okay to give the spacing also, guys. But here, this is the logic we have to write. The count is greater than 2 means that particular number, given number, is not only divisible by 1 and itself by giving the remainder as 0, but in other numbers also it's able to give the remainder 0, then only count will be greater than 2. In that case only, I am returning false. Otherwise, simply I'll return true. In other cases, it should be greater than 1. Okay, it should be greater than 1, and it should be only divisible by 1 and itself. In only 1 and itself, it should give the remainder as 0. In other cases, it should not give the remainder as 0. That's what we are checking, guys. Very basic rules we are following and running the Java code here, and observe that. Enter any number. If I enter any number like 10, range from 1 to 10, what are the different prime numbers we have? 2, 3, 5, 7. That's good. If I give any number like, let's say 99 or 100, I'll give. From 1 to 100, what are the different prime numbers we have? All the prime numbers will be printed. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73. So I'll ask Google also, just to know that whether we have written program properly or not. I'll ask the Google to give list of prime numbers in the range of 100. Okay. Let's see what are the numbers that are coming. If they are matching means I'll copy this and just verify this. Otherwise, just verify this, guys, in the output. So 2, 3, 5, 7, 11. 2, 3, 5, 7, 11. Okay. 2, 3, 5, 7, 11. Then, yeah, these 5 numbers are prime numbers. 13, 17, 19, 23, 29. 13, 17, 19, 23, 29. Matching. 31, 37, 41, 43, 47. 31, 37, 41, 43, 47. Correct. 53, 59, 61, 67, 71. 53, 59, 61, 61, 67, 71. Yeah, 67, 71. Right. 73, 79, 83, 89, 97. 73, 79, 83, 89, 97. You see, all the prime numbers from 1 to 100 got printed. You can give any number, guys, in the range of, in that particular range, whatever the list of prime numbers, all the thing will come. So if you want to know the logic here, guys, you can take the screenshot. I'll just stop it here. You can take the screenshot, how I have written the logic. This screenshot of the main method where I'm calling this is prime method. You can take a screenshot. And the reusable method that will be called for every iteration of that particular number in that range, right? Which will find out whether the given number is a prime number. This is the logic for that, guys. So if you want to take the screenshot of this reusable is prime number method, you can also take the logic screenshot of this, and you can practice it in your machine. Okay. So this is the code, guys. This is the code for writing the logic for checking whether okay, the given numbers, okay, printing the list of prime numbers in the given range from 1 to whatever the number that is inputted by the user. In that range, what are the list of prime numbers are there? This program is printing. With practical demonstration, I have answered this question for you. But before writing the code, you should have this basic knowledge of prime numbers. Prime number should be greater than 1 and prime number should be only divisible by 1 and itself. In only the two cases, you should get the remainder as 0 and dividing by 1 and itself. If any other number is able to divide that number and giving the remainder as 0, then that number given is not a prime number. So with this basic knowledge, if you write the code, if you think and write the code, then you'll be able to write the Java program without any problem. It is very simple. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, write a Java program to check whether the given number is an Armstrong number or not. Let me answer this question with practical demonstration. Before the practical demonstration, you need to first understand what is an Armstrong number. A number that is equal to the sum of its own digits raised to the power of the number of digits. Let me explain what does it mean. For example, if you take 153, how does 153 can become an Armstrong number? How to check that? Let me show you. The original number is what? 153. In 153, how many digits are there? 3 digits. Okay. Now, you have to take one of the digit, let's say 3 here, 3 power, the number of digits is 3 power 3. Okay. To this 3 power 3, you have to add the second digit, that is 5. That is second digit is 5. 5 power the number of digits. How many total digits are there? 3. 5 power 3. Plus, and what is the final digit we have in the beginning? 1. 1 power the number of digits. That is 3. So if you calculate this, 1 power 3 means what? 1 into 1 into 1. 1 into 1 into 1. That becomes 1 ones are 1, 1 ones are 1, 1. Now 5 power 3 means 5 multiplied by 5 itself 3 times. 5 5 is 25, 25 5 is 125. 3 power 3 means 3 into 3 into 3. 3 3 is 9, 9 3 is 27. If you calculate the total, 126 plus 20, let's say. Okay, 126. That is 126 plus 20 is 120. 146. 146 plus 7. What is 146 plus 7? That is 153. This so total is equal to 153. Okay. So original number is 153. And when you do the calculation like 1 power 1 into 1 into 1, number of digits is 3. So you have to divide every digit of the number with 3 times. Okay. You have to multiply every digit with 3 times. 5 into 5 power 3 means 5 into 5 into 3. 5 into 5 into 5. 3 times. Then 3. 3 into 3 into 3. Okay. So the result is 153. The original number 153, if it is equal to this result of this kind of operation, then this kind of numbers can be said as, they can be called as Armstrong numbers, guys. So that is what is Armstrong number. A number that is equal to the sum of its own digits after raising them to the power of the number of digits is an Armstrong number. 153, as I showed you, right? That's an Armstrong number. How to write a Java program to find out or check whether the given number is an Armstrong number or not. For that, I'll switch to Eclipse IDE. Here, I'm going to create a new class. I'll just name this class with some random name. Let's say class 21, and I'll create the main method. Now, in the main method, I'll collect the input from the user. So user has to give some input number and I have to check whether that particular number is an Armstrong number or not. That's what I would like to write the code for. So here I'll write scanner is equal to new scanner is equal to new scanner. And here I'll write system.in. I'll simply say Control Shift O and write down scanner system.out.println. Enter any number. Okay, enter any number for the user during while the program is running. The user, by looking at this print statement, will enter a number. That number will like to capture here into scanner.nextInt. Okay, this nextInt method of the scanner will capture that particular number given as input by the user. We'll store that number into NUM. Okay, let's say Now, I want to find out whether this particular number is an Armstrong number or not. For that, I'll create one more method, guys, public static method I'll create so that I can call that and find out whether that particular number is an Armstrong number or not. Is Armstrong is a method name is Armstrong. And here I have to get some value, like whatever the parameter. That is, for example, here I say n, okay, int n. This number is given to n, okay. So now here I'll write something like this. Int original number is equal to this n, okay. Whatever the original number we got, right, that has been inputted by the user, right, that I'll get it here and I'll assign to the original number. Now, first task I will do is how many digits are there in this particular number that is passed to this method while calling. I have to call this method here, guys, okay. I'll call this method. If method, like this, I'll write the logic. In this if condition, I'll call this method and I'll pass this number here. I'll pass this number like this, okay. Whatever the number that is received from the user, I'm passing as an argument to this parameter of this particular method, okay. And here this return type should be Boolean type, okay. If this is an Armstrong number, if this logic decides that this particular number is an Armstrong number, it will return true. For now, I'll write some return true so that we'll not get any error here so far. So later I'll change this. So int original number, whatever the number that is received, right? If that is an Armstrong number, means this method is going to return true here, and I'm going to print out system.out.println. Given number is an Armstrong number, okay? Else I'll print it out. System.out.println. Given number is not an Armstrong number, okay? Otherwise, Armstrong number, not an Armstrong number, simple, straightforward, I'll print, okay? It's not an Armstrong number, or Armstrong number will be printed here. Fine, looks good so far, but the actual logic we have to write here. Let me close the scanner object so that the task will be done in the main method. So here I'm going to write the logic. First, I have to find how many digits are there in this original number. How to find out how many digits are there? I'll write down while this original number, okay, original number, when I try to divide this original number, if that original number is not equal to 0, let's say, if the original number is not equal to 0, then I have to go to the while loop and iterate the while loop. And inside that, I'll find how many digits are there by writing down original number divided by 10. If I try to divide a number by 10, I'll get an original number, right? Okay. So here, if the original number is not equal to 0, I'll write down something like int digits or D. Okay. D I'll say. Int D is equal to 0, I'll say for now. And here I'll say D plus plus. If the original number is not equal to 0, I'll increment the value of D plus plus. Here original number is equal to original number divided by 10. Now what happens? The next iteration, the value of D will be incremented to 1. And in the next iteration, original number divided by 10. In the next, what will happen if you try to divide a number by 10? For example, if you have given this example like 153, if you have given, let's say 153 is given passed here. So 153 will go into the original number. 153 is not equal to 0, will go inside the while loop. And here D plus plus will happen. D will become 1 now. After D becomes 1, original number is equal to original number, that is 153 divided by 10. So when you divide a number 153 by 10, okay, if the original number is 153, if you try to divide this 153 by 10, the result will be 15, guys, okay? 10 into 15. 15 times you can divide. So 15 will be assigned to the original number. Now 15 will be assigned to the original number. Here 15 is not equal to 0. Here we'll go inside the while loop and D plus plus D will become 2 now. And here the original number is now 15. 15 divided by 10. How many times you can divide the 15? Only one time, right? By 10. 10 ones are 10. Remainder will be 5. So only one time. 1 will go into original number. 1 is not equal to 0. Again, we'll go inside the while loop. And here D plus plus will happen. D will become 3. And original number is what now? 1. 1 divided by 10. How many times you can divide the number 1 by 10? 0 times 10 zeros 0 and you cannot divide basically. So 0 times. So 0 is not equal to 0 will become false. And here will come out of the while loop. And the moment we come out of the while loop, we'll get the number of digits here, guys. The number of digits will be 3 here. Okay. So here D means digits. How many digits are there in the original number? We found it out. After finding the number of digits, here curly brace is stopped. Okay. Yeah. After finding how many digits are there, let's say 3 digits, let's say. Now, after finding the number of digits here, we have to find out whether the entered number is a Armstrong number or not. How to find out? Every digit we have to, for every digit we have to, uh, every digit we have to add. For example, if they have given 153, in 153 we have to add 1 plus 5 plus 3, but not directly, but we have to 1 power 3 because number of digits are 3, right? So 1 power 3, 5 power 3, 1 power digits, 1 power D, 5 power D, 3 power D. Like this, we have to calculate this sum. How to do that? Here I'll write int result is equal to, okay, result number is equal to 0, I'll say. Now I'll write the while loop saying, okay, while, again, original number, again, I'll do one thing, guys. This time, I'll again assign the original number is equal to n. Again, I'll assign that to n. Okay. After finding the number of digits, again, I'll assign the original number with this particular n value, that is 153. So, or you can create one more variable also if you want. Okay. So, if you don't want to take the same one, int on is equal to original number is equal to n, you can say. Okay. So, on, while on original number is not equal to 0. Again, you go with the same logic. Again, you are going with the same logic, guys. This time you will do in a different way. That is, you don't have to count it. Simply say original number is equal to, okay, on is equal to on divided by 10, I'll say. On divided by 10. Here, originally, what is there? 153 is there. Instead of dividing, we use modulus here to get the remainder. On modulus 10. 153 modulus 10 means the remainder 3 will come. The remainder 3 will come because after dividing the 153 by 10, the remainder 10, 10 5 is 150 or something. I like, 10 into 15 times 150 and remainder will be 3, right? That 3 will go into ON. Actually, it's not going. This 3 here I have to say as a reminder, guys. Okay, it's not ON. Actually, it's a reminder. So here I'll say int R. Int R means int reminder. Int R. R is equal to what will be the R? 153 modulus 10 means 3 will be the R. Okay. Now what I will do here is here I'll try to get the here I'll try to do something like this. Here result is what? Result number. Result number is equal to result number plus result number is already 0, guys. Okay, result number is equal to result number plus what is the digit we got? What is the reminder we got? R into R multiplied by R is a reminder 3 multiplied by how many times we have to multiply the 3, guys? R into this many times. That is number of digit times R into R into R. To make that happen, instead of saying R, right, here I will write R. Otherwise, I'll write some method like this, okay? In mathematics, there will be some method here. Math dot power. We have to find the method which can power the power of, okay? So, is there anything power? Okay, I'll take this power. Power original number is what? This particular number is what? The remainder. Remainder need to be multiplied by how many times? Remainder should be multiplied by how many times? Remainder should be multiplied by number of digits. So D I'll give. So what is the problem here? Math dot power int result math power cannot convert from double to. Okay, this is not coming. So I'll write down one more method. Math dot something. You should find a method here using which we can find the power of math dot power double is there, random is there, round off is there, Where is that method, guys? Let me find the method here. ABS. Or we have tried in a logic way, but exponential, no. There should be two parameters actually. I'll try to find out. Just give me a second. Max, minimum, multiply. Next after power is there here. Next up, next down, sign in, square root, subtract, radius. You have to find that, guys. Multiply. There should be some method for this. Let me check any solutions here. The logic is almost there, but we need to find the power of that particular digit number. So Java finding power of a number using math method. Let's see what it will come. Math class, there will be a predefined method, guys. I don't remember that. Just math.power is a method they are saying, but it's coming as double, right? Double result is coming. That's the problem. So we have used power, but it's coming as base comma exponent. That's fine. But the result is here instead of R, right? We'll say double here. And we'll typecast it later for now. For now, sorry, int only. Here result is double, I'll say for now. Result is equal to math dot power of, or we can also do one thing, int result we'll say. And here we have typecast. We'll typecast that into int type, okay? I'll typecast that into type so that it will take it power. Math dot POW of, here we have to give the reminder, that is 3 R I'll give. And after R, we have to give the D here, digits, number of digits. We have to multiply this R, the number of digit times. Okay. Like this, we can write the logic, and after the double result will come, that I'm going converting into integer type and adding with the result number, and that result number will be updated. And after this part is done, I have to say original number is equal to ON divided by 10. So in the next iteration, 153 will become 153 divided by 10 will become 15. So 15 is not equal to 0. Again, we'll go here. 15 modulus 10. What will be the remainder, guys? 5 will be the remainder. So R will become 5. So in the earlier result, it was 3 into 3 into 3, 0 plus 3 multiplied by 3 times. 3 3 is 9, 9 3 is 27. 27 was the earlier result. 27 plus, the result will be 0 plus 27. 27 was there. Now 27 plus, here math dot power of R is coming as 5. 5 power 3. Number of digits has come as 3. 5 into 5 into 5, that is 125. Okay. So 27 plus 125, that is, it will become how much, guys? 152. 152 will be the result. 152 will go into the result number. And again, okay, the next 152 here. Again, what happened in the third iteration? Original number 15 divided by 10 will happen. That 1 will be going here. 1 not equal to 0. True again. 1 modulus 10 means remainder will be 1. And here result number is what? 152. 152 plus math dot power of remainder is 1. 1 should be multiplied by itself 3 times. 1 into 1 into 1 is 1. So here 152 plus 1 will become 153. The result is 153 will go into the result number. And ON will become 1 divided by 10. 1 divided by 10. How many times you can divide the 1 by 10? 0 times. 0 not equal to 0 will become false and will come out of the while loop. And result number, by the time you come out of the while loop, the result number will be 153. The result number will be 153 and the original number is N. Okay, original number is N. Okay, so here I'll simply write down. Okay, I'll simply write down. So this kind of logic we have tried, guys. Otherwise, you cannot get it. If the N, original number N, whatever that is passed, is double equal to this result number, if it is double equal to result number, then return true. That means it is an Armstrong number. Else, return what? False. So I don't have to return anything here. You can just close it. Okay. If else conditions in the Boolean. So like this, we can write the logic, guys. Okay. Original number, you can take it 2 times and you can do that like this, something like this. N is the original number. Just for this operation, you are going to use this temporary original number. Okay, you can say TON, temporary original number, if you want. Temporary original number, temporary original number, temporary original number. Okay, again here also you can say temporary original number is equal to n again. You don't have to declare again, already it is declared here, but again you are assigning the original number here. Okay, so you can say ON here, ON, original number. ON means original number, or you can also write original number. Okay, you can also write original number and assign that original number here. This will be more easy. So here again assign the original number, TON, temporary original number, temporary original number. I would write instead of ON, I'll write temporary original number, temp original number, temp original number. Okay, like this you can write the logic. And if this original number, now you can write the code like this. If original number is equal to the result number, then return true, otherwise return false. So if you run this code, this program will print out whether the given number is a Armstrong number or not. So run this code, right click run as Java application. You can take a screenshot of the scanner, main method having the scanner code. Okay, meanwhile. So here, if I give 123, not an Armstrong number. Okay, it's not an Armstrong number, it is saying. Now, if I run this code and if I give 153 this time, 153 is an Armstrong number, right? If I run the code again, right click run as Java application, enter any number will come. 153 I'll type. 153 is an Armstrong number. You see, Armstrong number is coming. That means the program is working fine. You can take a screenshot of this code and I'll scroll down now. After you have taken the screenshot, now scroll down and I'll give you the code of this. Okay. Okay, it's a very big code actually. Okay, almost there. You can take the screenshot of this code, guys. You can take the screenshot of this code. Okay. So this is a reusable method which will find out whether the end given passed number is an Armstrong number or not. Okay. From the main method, by collecting the input from the user, we are passing to the method the Armstrong number. That Armstrong number is the original, that whatever number that is the original number is an Armstrong or not, we'll find out by writing this logic. First, we have to find how many digits are there in the number by giving D and D plus plus. D will give you the number of digits. And after that, after finding the number of digits, to see whether that is an Armstrong number or not, we have to dismantle all the digits of the number and multiply that every digit with the number of digits of that number. Okay. So in that 153, we'll take the remainder 3 and 3 into 3 into 3, 3 digits, right? 3 into 3 into 3, 27. Okay. That will store it to 0 plus 27. 27 will come. Later, we'll divide that 153 by 10 and 115 will come. 15 not equal to 0. Here, remainder will come as 5. Again, result is 27 plus 5 into 5 into 5. 3 times. 5 power 3 means 5 into 5 into 5. We have this method. You have to typecast that into type. Other we are getting error. So 125 plus 27. 152 will come. And finally, the remaining number 1 will, after dividing 15 by 10, 1 will be there and 1 not equal to 0. The remainder will come as 1. And result number is 152, earlier result. Plus 1 into 1 into 1 is 1. 152 plus 1 is 153. The result number has become 153. And when you try to divide the number 1 by 10, 0 will come. 0 is not equal to 0 will be false, will come out of. Here we have separated each and every digit of the number and made sure that each and every number is multiplied number of times the number of digits are there and added to the resultant number. Okay. And finally, the original number and resultant number are compared here using double equal to symbol to find out whether that is if it is equal, if the original number is equal to the resultant number after this operation, then that number is an Armstrong number. Otherwise, it's not an Armstrong number. So that's how we have written the logic, guys. That's how we have written the logic. So hope you got the idea of how to write the programming logic for finding out or checking whether the given number is an Armstrong number or not in Java programs. Okay. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, write a Java program to print Floyd's triangle. Let me answer. So before I practically demonstrate, let's understand what exactly is Floyd's triangle. Floyd's triangle will look something like this. In the first row, it will start with the number 1. In the second row, after 1, what will come? 2, right? 2 digits will be there. 2 numbers will be printed in the second row, starting from the next number of 1, that is 2 and 3. After 3, what will come? 4, right? In the third row, it will start from 4. And in the third row, 3 digits starting from 4. 4, 5, 6. After 6, what will come? 7. In the fourth row, starting from 7 to 4 digits, it will come 7, 8, 9, 10. And after 10, 11 will come. The fifth row will start with 11 with 5 digits, 11, 12, 13, 14, 15. If you have more rows, here 16, 16, 17, 18, 19, 20, 21 will come. 22 onwards, 7th row and go on. Okay. This is what is a Floyd's triangle. How to write a Java program which can print such kind of Floyd's triangle. Here, what I will do in this program is I'll try to collect the number of rows. Okay. For the Floyd's triangle to be printed. That input I will take from the user during the runtime. And if the user inputs 5, this kind of Floyd's triangle will come. Okay, it is right-handed kind of triangle, right-handed. You see this direction is to the right side. It looks like a triangle moving on to the right side. So it's the right-handed triangle. So, but here number of rows I'll index from the user. But depending on the number of rows, the number of numbers, you see, if I take 5 rows up to 15, it is coming. If I take 6 rows, 16, 17, 18, 19, 20, 20, up to 21 numbers will come. Okay, and so on. That how many rows the user wants to this particular Floyd triangle to be printed with. That input I will take from the user, and remaining all logic I'll write for printing the Floyd triangle. For now, I'll switch to the practical mode to this Eclipse IDE. Here I'm going to create a new class. In the new class, I'm going to write the code for printing that Floyd triangle depending on the number of rows inputted by the user. I'll create a class. I'll just name this class as class 22. Class 22 with main method. I'll create, click on finish, and here inside the main method, write down the code for taking the number of rows from the user. Scanner is equal to scanner is equal to new scanner, scanner is equal to new scanner. Control Shift O, and here try to write down system.in. Okay, then after that, write down scanner.nextInt, and before you collect that number of rows from the user, write down a print statement helping the user during the runtime to enter the number of rows. Enter number of rows. Okay, for Floyd's triangle. Okay, Okay, Floyd's triangle. Enter the number of rows for Floyd's triangle. Here I'll capture the rows. Int rows is equal to scanner.nextInt. After that, the job of the scanner is done. You can close this if you want. That's up to you. The scanner object you can close once the task is done. In taking the input from the user is done, you can simply close the scanner object. You don't have to close it at the end of the program. You can close it at any line after the input channel is closed. Okay. After the input is done, you can close it anywhere. Now I have to write the logic for printing the Floyd's triangle based on the number of rows. So I'll write something like this for int I is equal to 1, starting from the first row till which row I less than or equal to rows, I less than or equal to number of rows. That many rows should be there. I plus plus, I'll write like that. In that, I have to write another inner for loop, nested for loop. I have to write int j is equal to 1. How many numbers in that row I have to print? I have to print depending on the row number. I have to print that many number of numbers. For example, in the first row, I is 1. In the first row, I is 1. 1 less than or equal to, for example, if the user has given 5, 1 less than or equal to 5. The rows are, row number is what? Row number is 1. R is equal to 1, let's say. Okay, I is equal to 1 is row number 1. In the row number 1, how many numbers should be printed? That should be equal to the row number. That's why j is equal to 1. J less than or equal to I have to say. Okay, only that particular number of numbers I have to print. In the first row, I have to print only 1 number. In the second row, I have to print 2 numbers. In the third row, I have to print 3 numbers. That's why I'm giving j less than or equal to I, j plus plus. Depending on the number of row, that particular number of iterations this inner for loop will iterate. That you have to understand. But what we have to print basically, initially, int n is equal to 1, I'll say. Okay. So initially, I'll say int n is equal to the number 1. Okay. So here, I'll print out system.out.print. Instead of ln, I'll say print, guys. And I'll print the value of n. Okay. I'll print the value of n and give a space here so that the next numbers will have some space. Otherwise, it will be very clumsy. So after this n, I'll say n plus plus. The next number that need to be printed should be after 1, 2 should be printed. After 2, 3 should be printed. That's why I'm using this logic, guys. Here we are not either printing I or j, we are printing n here. Initial value of n is 1. In the first row, what will happen into I is equal to 1 in the row 1, 1 less than or equal to 5, let's assume, we'll go inside that. J is equal to 1, 1 is less than or equal to 1. That is true, we'll go inside that. Here, the value of n is 1, 1 will be printed. In the first row, 1 will be printed. In the first row, 1 will be printed, and then n will become 2, n will become 2 here, and here j plus plus will happen, j will become 2. 2 less than or equal to 1 is false, will come out of the inner for loop. And after that, I have to go to the next row. For that, I've used println statement here so that I can go to the new row. Okay. And here control will come to I plus plus, where I will become 2. This is the row 2. When I becomes 2, it's the row 2. 2 less than or equal to 5 is true, again will come inside. Here j is equal to 1. 1 less than or equal to 2 is true. We'll go inside that. The value of n is currently 2. So 2 will be printed here in the next line. In the next line here, in the new row, 2 will be printed because the value of n is already incremented to 2 here. Now, n will become 3 after printing 2 and space. The n will become 3. And here, j will become 2. 2 less than or equal to 2 will be true again. Will come inside. The current value of n is 3. 2 space 3 will be printed. And then we'll go to the, and then j plus plus will happen where j will become 3. 3 less than or equal to I, that is 2, is false. We'll come out to the inner for loop. We'll go to the new line. Once we go to this new line, it will be like this, guys. It will be like this. We'll go to the new line. And here, okay, the value of n has become 4 by this time. After printing 3, right, the value of n has become 4. And here I plus plus happened. R will become 3 here. So j is equal to 1. J is 1. J is 1. 1 less than or equal to 3. I is 3 here, or row you can say. That is j is less than or equal to 1. That is j is 1. J is 1. 1 less than or equal to 3 is true. We'll go inside that. Current value of n 4 will be printed here. Okay, 4 will be printed here with a space. After that, n plus will become 5. J plus plus will happen. J will become 2. 2 less than or equal to 3 is again true. We'll go inside that. Current value of n 5 will be printed with a space. Then n will become 6 here. J plus plus, j will become 3. 3 less than or equal to 3 is still true. We'll go inside that. Current value of n 6 will be printed here with a space and go to the new line. So here n will become 7 and we'll go to the new line. And here the next println, we are going to the new line here. I plus plus, I will become 4. Okay, I will become 4. 4 less than or equal to 5 is true. Number of rows is 5, let's say. 4 less than 5 is true. We'll go inside that. J will become 1 here. 1 less than or equal to 4 is true. The current value of n is 7. 7 will be printed here with a space. Then n plus plus will happen. N will become 8. J plus plus, j will become 2. 2 less than or equal to 4. True again. Current value of n 8 will be printed. Then n will become 9. J plus plus, j will become 3. 3 less than or equal to 4 is true. The current value of n 9 will be printed with a space. N will become 10 here. J plus plus, j will become 4. 4 less than or equal to 4 is true. We'll go inside that. Here current value of n, that is 10, will be printed with a space. Then we'll go to the, here n will become 11 and we'll go to the new line because of the println statement. Because here when j becomes 5, 5 less than or equal to 4 is false, will come out. So we'll go to the new line. And here I will become 5. 5 less than or equal to 5 is true still. We'll go inside that. J will become 1 again. J will become 1. 1 less than or equal to 5 is true. We'll go inside that. Current value of n, that is 11, will be printed here. 11 will be printed with a space. With a space, it will be printed. And after that, n plus plus will become 12. Then we'll go to j plus plus. J will become 2. 2 less than or equal to 2 less than or equal to 5 is true. We'll go inside that current value, that is 12, will be printed with a space. Then it will become 13. J plus plus, j will become 3 here. 3 less than or equal to 5 is true. Current value of n, that is 13, will be printed here. 13 will be printed here somehow. Okay. Space will be printed. Then n will become 14. J will become 4. 4 less than or equal to 5 is true. We'll go inside that. Current value of n is 14. So 14 will be printed here after the space. 14 will be printed here. Okay. 14 will be printed here. After 14 got printed here, then n will become 15 and j will become j plus plus 5. 5 less than or equal to 5 is true. Current value of n is 15. So here after a space, 15 will be printed. Then n will become 16. Then here j will become 6. 6 less than or equal to 5 is false. We'll come out of the inner for loop. We'll go to the new line here. We'll go to the new line. Okay. We'll go to the new line. And here I plus plus will happen. I will become 6. 6 is less than or equal to 5 is false. We'll come out to the external for loop. So this kind of Floyd's triangle will be printed because of this logic. So hope that you got the logic, guys, how we have implemented that. Okay. So like this, if you write the code, you can print the Floyd's triangle. Okay. And we just get the number of rows from the user and remaining part program will take care of. Okay. So let's run the code and see. You can take a screenshot of this code if you want to practice later. So right click run as Java application. Right click run as Java application. Enter the number of rows. If I give the number of rows as 5, you see 1. In the first row, 1 is there, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 got printed. If I give 10 rows, you see very big Floyd triangle will be printed. If I give 10 rows, I'll give 10 here. You see, it will be very big Floyd triangle. You see, like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Up to 55 got printed. Number of rows will be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Till 55, the numbers got printed. Like that, any number you give that much bigger, any big number you give that much bigger, Floyd triangle will be printed with the help of this Java program. So hope guys, you got the answer for this question with practical demonstration in this session. So that's all for this session. Thank you. Bye-bye.